I'll start recording now. But anyway, let's see. So it's the system on a chip, right? It's got a microcontroller, but it also has all these analog parts to it. I don't know, the splash page is a little overwhelming, but what I have are here we go, is I have these development kits. I have a whole office full of them because my contact at Cypress needed to make room. And so the problem is just getting them to you all. So now next week I'll be on vacation, but yeah, if I can just have a day where people come down and just pick them up, right? It's a whole development board. And what's kind of interesting is it's got the programming chip. And then if you're happy with what you have, you just break it off and then that's your design. I guess, I don't know, they're $15 now, but yeah, I've got a whole bunch effectively for free. And I have a guy who'll come and give a talk about how to use them and how cool they are, which I'm not really demonstrating very well right now. But that's something for the future we can consider. So what I just wanted to throw out a question is that in 110, the success rate isn't really where I want it to be. Okay. Now there's a lot of things I don't have control over, but each year I try to come up with something to try to improve things. And so last spring, I made these module notes for each module. Like here's like the review, right? And I guess it takes a while to load in. So yeah, oh, that's the final exam review, not the. So, but anyway, I would come up with these modules, and it's effectively like a shortened version of my notes, and it would have the Python code and everything like that. And that took kind of a lot of time. And then what I would do, which I'll just describe because I don't feel like logging into Canvas right now, is I would have a homework assignment, and then I would have case studies on previous ways to do that. Now, the new thing would be, it's called a transparent assignment, where you not only do you have just, here's what you have to do, right? But up front would be a little blurb on why you have to do it. That, this signal manipulation is done in industry, it's done here, you'll use it later on in another class, things like that. And then you even give a little grading rubric about how you're graded, right? Maybe like this. Trying to find an example. So Like, here's an assignment. Tell me what it's made out of, ramps and steps, and you'll be graded on getting each one, the delays right, the scale factors right, and the functions right. Right. I would kind of spell that out. Right. Yeah, like here's like a midterm, like one question, right? So you're given this, and then I tell you how you will be graded on it, right? Um, and then if that were the homework question, or this could be, here's a sample problem that I'm going to do out for you, and then somewhere else there'd be, here's the actual problem that you're going to do. So those are transparent assignments, and those I kind of have those, right? But it'll take a lot of kind of effort to program that and to do that, right? The other things I've done are making sure that the online tests are accurately measuring what you should be learning, right? But and here's my air quotes, as stress-free an environment as possible, right? Without the use of lockdown browsers and a whole slew of other things, right? Which took some time. But then at the end of last semester, it just seemed like, oh, then another thing I had tried was, I thought that people were really struggling with the EE98 review. So I kind of formulated the first part of the class to do more EE98 review explicitly, right? So I tried all these things, and actually had the worst pass rate ever in that class, which it might have been beyond my control. But so given all that, I had thought, maybe if I had spent my time developing in-class exercises where people would get to know each other and learn the material, maybe that would have been a better use of my time, right? I can come up with better assignments, or I can spend my time having people getting to know each other. And I'm wondering what and I'm gonna go around the, I'm gonna go around the loop here. I'll just call your name out, and then you can kind of tell me what you feel like, where do you think I should be spending my, oh, take care, Ryan.
Thanks. Sorry for cutting it short. But
oh yeah, if you could email me your response, that'd be great.
I will. Yeah.
Okay,
definitely.
thanks.
Okay.
All right, good luck.
Bye.
Okay, so oh, Alex has her hand up, so I'm sure you have plenty to say. So Alex, why don't you go first?
Yeah. Okay, so like one thing is the things that you tried, I mean, they sound good and like they could be on the right track, but of course, as you already know, like it's hard to correlate that with the feedback. Like that the pass rate was lower may have just nothing to do with it. I mean, like one idea is that for me, the first semester of SJSU as a junior, that was like huge. And so the shift in skill and everything that it required was completely different from where I'd been the semester before. So I think that those efforts are good and worth doing. With your question, is it better to spend time on revamping or changing assignments like that, or building networks inside of class? Well, the math class I took this semester has kind of changed my perspective on that. He sent out an email before the whole thing started and said, if you don't network, you will not do well and you won't be able to pass this class. And so the entire class is focused around students being, I mean, you can't make a horse drink water, but you can lead it to the river, making students network. Both the structure of the class has breakout rooms. I think our midterm, the first half of the midterm was in a group fashion. I can elaborate on all this like later if you're interested, but the gist of it was help students, which in this class are majorly high school students, understand how to network even in difficult times like these. And I think a part of that is your class, but a big part of that is what happens after your class and how do students succeed. And especially during COVID, when I think we're isolated and it is difficult to network, that may be more than ever powerful, because it is working with other students that helped me survive 110 in other classes that semester.
How I have read about this collaborative midterm business, and when I first read about it, you know, my head exploded. How did that? Now we have somebody who does it in the college, and I can ask him. But how did your instructor do it?
Yeah, and I'll be happy to share like the whole class format and how it worked. But like, we were thrown in a random room. I think it was an hour and a half to 2 hour midterm. There were 5 or 6 problems, and we just worked through them, and we're supposed to submit no partial credit. Either you got the answer, you didn't, and honestly, I think I got 39 out of 50. So we had a pretty happening group, but it really, the reason it worked kind of is because we had groups that we had to do weekly. So we were forced to do this 2-3 times a week, and you got better and better. The way that he facilitated this, even though it was a group thing, is there was a second part, and it was totally individual. He
Right.
didn't tell us, and I don't know how you do this, but it was actually the exact same questions from the first one. And usually our grade, even though it was math, it was only based on first describing what we were going to do in our process and our logic, and then actually executing it with calculations. So it ended up being less like sharing the answer would get you anywhere, and more like he knew what our voice was, and we had to describe how we were getting there, and that's how we were graded on the
Which came first, a group or individual?
group. And it explicitly stated in the instructions, you know, the point of the group is you may get it wrong in the first part, but take these home, network, you know, figure out what the answers are, because we didn't know they were going to be the same questions. But the idea is, you know, facilitate that skill of getting it wrong, but going back and figuring it out and solidifying it.
So you were assigned randomly, you worked for a certain amount of time, and then when did you take the individual part?
2 days
Later?
later. 2 days
2
later.
days later.
Yeah.
Huh.
And there's probably a syllabus from the full semester version. And
Yeah, no, you know, it's weird, but I used to do, you know, when it was face to face, I would give out a sample midterm and everybody would work on it, right? And then in groups, right? And then they would finish it up. But no, the individual part was never it was never the same question, but it was only just a homework. But I'm thinking, well, actually, what if I said, you know, this group part is actually part of your exam grade, right?
yeah.
Because what I noticed is people would just spend their time only looking at that sample exam and coming up with whatever answer and kind of memorizing it. So, but it may be,
Well,
anyway, that's really
yeah.
food for thought. The same thing. Oh, I don't know, but that's actually not too far off of things I've tried. But I think the thing is your instructor also kind of had you practice this, which I
Yeah.
hadn't. But yeah. Oh, is somebody else got something to say?
I think
Okay, no, sorry, I didn't want to cut anybody off. Oh, all right, Alex, thank you. That's food for thought. Oh, but sorry, just one follow-up question. You said your mind had changed. So does that mean before this summer class, you would have thought that spending time on getting those assignments in a particular way would have been better, and now you're thinking, no, teamwork is better?
Yeah, I had yet to see it done successfully, even in classes that were, you know, breaking the mold in person when we transitioned to COVID and online, they weren't succeeding. And I still thought number one thing is helping students collaborate, but I wasn't sure how to bridge that gap. And if you asked me number one feedback thing on 110, I would have said data organization. So I think you're on the right track. It's just somebody did it right.
Well, no, you already, yeah, no, you're already pretty clear on that. Which is probably what those modules I did in the spring were all about. Oh, and sometimes just cutting information, like, wow, I've just got too much here. Okay, Edward, what do you have to say?
Yeah, actually, I think what Alex brought up was a great point. I think something along those lines also was kind of just like I think making I agree. I think like on your end, you're putting as much effort as you can. So I think what you can do is try to make it easier for students to connect with each other, because I think no matter how at the end of the day, no matter how approachable some professors are, and you're definitely one of the approachable professors, I think just because a lot of us are STEM majors, we I think a lot of us get intimidated to ask, you know, the professor or reach out to the professor, and no matter what you do, like it's just not something that they're gonna do. I think.
Oh, listen, my enrollment is probably going to be over 100. I don't know what I would do if everybody was as interactive as you all.
So
So you do need your friends and getting
right.
immediate answers. Yeah, yeah.
Exactly, and what Alex is saying. So, but what I do know is that the students that do tend to succeed tend to like actually do collaborate a lot. Like what happens is that they end up forming their own groups and studying
Right.
together. And a lot of how that I think forms is through like Discord. Like they just have their own Discord group and then they just hang out and chat. And it's not just like working on homework together. It's also like just having a just chilling in, you know. I think Discord is an environment that really promotes that. So what I think could be an idea would be maybe you have like a class back Discord where you just let everyone know in the beginning of the semester, hey, you know, this is my class's Discord for this semester. And just I think have the same mindset as what Alex is saying, and saying like if you don't collaborate in this, you won't succeed. So so I think instead of having these separate disjointed Discord groups, because I've seen that like yeah, the small groups of students that are successful tend to do that, have um like basically a class sponsored Discord where it's just like, hey, everyone has access to this, because I do think that the people who do collaborate on Discord and get to know each other does seem to have some sort of advantage over um over the individuals that just don't know anybody and kind of have to figure it out on their own.
Okay. Yeah, sometimes I feel students need to be able to talk without the professor kind of knowing. So I didn't get involved with that, but maybe it's a good idea to say, here is the Discord channel. You know, it's official.
Right.
And what are your thoughts about like assignments that you know, post on Discord, get a point?
I think some motivation, maybe like some initial motivation, it would be really
Okay.
nice. Like it won't even need to
All
be
right.
like the entire semester, but like I think some sort of like grade incentive in the beginning would I think get people active. And I think that's the most important part. If you get an active Discord, people aren't gonna just be like, oh, I'm doing this for a grade. They're gonna realize, wait a second, I'm using this, and they're familiar with it, and they're realizing, wait a second, this is actually something useful. So it doesn't need to be something you do for the entire semester, but just maybe just tinker around a little bit to see like what you can do to promote that. And I think especially just because a lot of students are also commuters, I think it's just
Yeah.
some people just don't know anybody in that classroom, and giving them like at least one way for them to realize, oh, there is this one thing that can get you in contact with others, especially when it's all virtual, like the past, you know, it's
Yeah.
turning out a lot of virtual. I think it'll be very helpful for some students, not everyone, because I think like for example the people who would have already been successful regardless would do something like this. I think this would be more for students that don't really know or haven't ever know, like doesn't really know how to do this kind of stuff on their own.
Okay. Sahil, how about you? Hey, Sahil, do you have anything to add?
Not really.
No? Okay. Are you unused to professors asking your opinion?
Yeah.
Well, when you're rich and famous, we'll want to know everything you have to say. Anyway, if you think of anything, you can just message me.
Will do.
How about you, Pranav? What do you think?
I think Edward made a really clear and good point, and yeah, I don't really have anything to add to that.
Okay. Well, let me ask you. Alex had talked about these group. It's a midterm, and you have a group part and an individual part. How do you think that would work when, you know what it's like? There's some students who are keeping up and some students who aren't. And how would you feel if you felt you got stuck with those that weren't putting in the time?
Uh, uh, yeah, I'm not really sure, but I guess in terms of grading for the group part, there should be, I guess there should be points on like on who on like participation.
Yeah.
Yeah.
You know, there is something that sometimes when you're the teacher, you might think, oh God, I'm with a bunch of people who didn't prepare or maybe don't understand it yet. But if you had been the role of the teacher, actually it can really solidify your knowledge. Sometimes I don't really know a subject until I've taught it, which maybe is a bit scary, but yeah, okay. All right, Gilbert. Thank you, Pranav. So Gilbert, what are your thoughts?
Yeah, I think open the group Discord is a good idea.
Okay.
I will say we cannot just focus on the group. We can have also a discussion group and be evaluated every student, or outside the class you can maybe organize a, a I mean group evaluation, kind of know who did this, who did that, and grade each and grade everyone according to what he did in the discussion. So maybe in terms of a midterm, it could be maybe 20% of the grade, of 20% of the midterm grade, and try to evaluate it, everyone according to what he did. Yeah. Or we can have
Yeah.
more discussion group. Yeah.
Yeah. Okay. All righty. Well, that's certainly food for thought. And I think the clear winner is teamwork. and that's where I'm probably gonna put my effort. Although making the assignments transparent maybe isn't so much work. And so I'll probably try to do that as well. All right. So I really appreciate that.
I do
Oh,
find the
just
group midterm idea really intriguing. I've never heard of it, but yeah, I'm wondering if there's some sort of way to make it so that um, even if it's the same question, you can't really just, it's not really the type of question where you can just copy it, because I do agree, and it seems like I do agree that maybe it depends on the type of problem, where maybe for 110 you can literally probably just copy like the work, and it won't without really understanding it, because it could be one of those things where, or it could, like for example, or another class where for another class you can't really do something like that. So I'm wondering if it's something specifically applicable to 110, or if there's some sort of way to design the question so that even if you worked on it together as a group, it won't necessarily translate to if you do it on your own.
Yeah, I mean, the thing is I could radically rechange it instead of kind of asking these very granular questions, you know, design a filter that cuts off frequencies above 1,000 hertz and gives a gain of 10, right? That's pretty open-ended. You know, verify your results, you know, show your work, your design procedure, and verify it in LT Spice, right? And verify it with Bodhi and a step response, right? So that's pretty open-ended, and it doesn't take much to have different problems. But the problem, you know, all I have to do is change the frequency and the gain, and you've got a lot of different questions there, right?
I think a bit of why this worked in this class, and I don't know if it really translates over, is because of all the group assignments. Everything was in explaining what you were going to do. It didn't matter if you came to the right answer, if you couldn't explain how and why you got there. So like the analog here is with designing this thing, you couldn't just say, you know, here's the calculations, but it'd be like, I picked this, you know, arrangement because XYZ. And, you know, before I did that, I had to draw a diagram. And before I actually hashed out the numbers, I threw it into LT Spice, blah, blah. That way, I mean, I couldn't go into the individual midterm, and it took a lot of time to even write out my process. So it's like you had to know it already when you kind of got there, or you weren't going to have enough time to write it all out. I don't know if that's right or wrong.
Oh, well, no, that's I think my struggle with the open internet format is that people study a little bit less hard because they think they'll have all the answers, when in fact you have to it's just like any exam, you have to know it before you go in.
Yeah.
Yeah, it's something I have to look into, because yeah, grading those actually takes a lot more effort, and with, you know, 90 students, I don't know if some things are possible, but it's certainly food for thought. Okay. Anyway, for today, I thought I could just go a little bit over it's kind of like using op-amps to solve differential equations. All right. And let me just see. So the notes would be nuclear. The one I'm going to show right now is nuclear decay. Okay. And then, since, yeah, wow, that was really a long conversation, but thank you, everybody. I appreciate it. Okay. So I do have some videos that show how to use this switch capacitor system. All right. You can watch those on your own, but the like that stochastic resonance that I showed last week, one with the Schmidt trigger, which was a circuit, but then the one I showed before that was a differential equation. You can take a differential equation and implement it in op-amp circuits. Now, yeah, generally it's considered it's easier, fast, you know, to simulate things using Python or a digital computer. But for, you know, there's still applications for analog simulation. And, you know, just depends what you're doing. Now, this is an old example, but the to simulate the Apollo missions, they had what was known as an analog computer, which is a bank of op-amps and multipliers and configured as integrators to put in the differential equations, and then it would kind of plot out the path on an oscilloscope. Now, then they used a digital computer to then verify that the analog was working. But that digital simulation took weeks at the time, right? Where the analog one, it did it, very rapidly. It just starts running in a sense. But I thought, let's just talk about nuclear decay because it's easy. So if we have the number of we want to know how much nuclear material we have left after it's decaying, right? So what is the number of the number of atoms or number of grams? I believe it's in grams later on, right? So you start off with your initial condition, and then you have exponential decay, which, right now you could be thinking, that kind of looks like an RC circuit, and I just have to change these. Now, yeah, we already know the solution to this, right? So we don't really have to simulate it, if you will, but it's a great example to start. So if we want to know how this responds in time, right, what the difference, the derivative of the nuclear amount of nuclear material with time is equal to minus some scale factor times whatever it is you have, right? And I guess I've said it's in kilograms. All right. So a lot of differential equations, they keep it in differential equations. And but when you're actually going to use op-amps, which have differential circuits, you switch it to integrals because the integral circuits are less prone to noise issues. So what we do is we just integrate it, right? So we have N, the amount of nuclear material, minus the scale factor, 0 to T and d tau, right? Because we're integrating and, the upper bound is time. So we have to do that change of variable, right? So in order to do that, we just have to have some initial condition, right? Now, because if you look at it, there's no x squared or anything like that, right? We can convert all this into the S domain because that's a little bit easier to see, right? So that integral, right, just becomes 1 over S, which as a reminder, that 1 over S, yes, it's the Laplace transform of a step function, but it's also the Laplace transform of their integral, right? Which, yeah, if you look at the Laplace transform equation, right, if you put in a constant, right, and start at 0, well, it's an integral, and that's basically integrating a step function. So it is the same. Anyway, so we can go through, come up with a transfer function, right? And then take the inverse Laplace, and we get, our exponential decay, which, is pretty standard stuff, and it could have just been an RC circuit. And the reason why you would do that if it exists is so that you can check whether your model is working or not, right? So anyway, this is the equation we want to put into an op-amp, right? And again, we can use the S domain because it's all linear, right? If not, I'd have to use integrals. So here's my summer, right? I'm adding these two things, the integral plus, right? And so, yeah, in an interesting way, where we're taking it is the high pass node. If this was just 1 over S and I was taking it here, it'd be a low pass, first order low pass filter, right? So I've just put that there, right? And, you know, I just go through and check that. In fact, I'm getting what I'm supposed to be getting, right? Which when I do, I get S divided by S plus lambda, which is a high pass function. So now we have to convert this into a real circuit. Now, the thing is if I have a megagram, right, how do I convert this into signal voltages, right? So if my initial condition is, you know, I have a megagram and I say, well, each gram will be equal to a volt. Well, then I need a system that could have megavolts, right? That's not going to work, right? You know, commons, you can go up to plus or minus 15, but modern power supplies are scaled down even. So that's the first thing. Then the second thing is, if I want to simulate this, I want to know what's going to happen, you know, right away. So what if the half-life or that lambda figure, right, is in years or one over years, right? Or decades, right? So that for a half-life, I have to go 3 decades for to see half the material leave, right? Well, I can't let my simulation go for decades, right? I have to speed it up. So basically, it's easy for this, it's just easy to scale. So if I say, hey, the maximum voltage is 1 volt, I'll just say 1 volt equals 1 megagram, right? And then I can just scale that lambda so that it's 1 over tau, right? And so I could say the nuclear material will be effectively gone in 5 tau. And if I set lambda, you know, like, yeah, if tau equaled 20 years, then my simulation would be 100 years. So if I set lambda equal to 2500, 5 tau would be 2 milliseconds, right? So I'd be able to get my solution a lot faster. So yeah, each millisecond is equal to 50 years. Now this is the cool bit, a cool bit, is this, right? Well, you've done this in 110, that's a summer op amp. This is just a scale factor, it's just plus, right? So I can take care of all of that in the summer. And then this is our inverting integrator, right? So it takes 2 op amps and everything would be controlled by resistors and capacitors. All right. But here, this is a summer and it comes with a low pass filter built in. But the important part is that's where I'm adding something. And then rather than an op amp, right, I've got, here's an inverting integrator, right? So because, right, we got an inverting sign here. So if I'm going to integrate, I have to, so I sum, I integrate, and then I multiply it by -1, right? And then feed it back here. But this is also the output. So we scale that with a another inverting so that we get the, you know, positive values give you positive nuclear material. All right. Or just let me do it. So you just wire this up and program it, and then it's, so you can simulate this and it takes a while, but you can put this on a board almost instantaneously. So if I press click, it'll go 1, 2, 3, bing, and it's done. All right. And then you can have Scopy all hooked up for it to do that. But you know what we have here is you know, here is our nuclear decay. So this is how much is present. This is how much is gone. And of course, with the step function going positive and negative, or like when you have a step function then go down, right? Yeah, you're getting a negative, like there's negative material, which doesn't exist, right? So you would just ignore that. So that's kind of the simplest example of converting differential equations into like an op-amp type circuit. I thought I had, trying to find, so yeah, data management is something I have so much of it. I'm still, no, that's not it. Sorry. I thought I had somewhere a description of what a switched capacitor circuit was. I'm sorry, guys. I'm not gonna force you to watch me search for something. But anyway, so that so if we go back, oops, excuse me. So if we go back to that stochastic resonance, there we go. This differential equation, okay? You can turn that into an integrator and then actually simulate it with op-amps, right? You can also simulate it with that switch capacitor. So that's, again, one thing that one could do. Also, the other one I'll mention is that there's this differential equation here where the voltage equals the integral of voltage squared plus some input. That's actually a neural model, right? Which can be used in AI and things like that. And it's subject to some conditions, of course. but you can convert this into op amps, right? Or the switch capacitor. And this is just showing how to scale things so that it actually, but LT Spice, you can do, you know, integrators there, and just, you don't even have to do an op amp. You can just write out these equations. And then you do use an op amp circuit, and then you can tell the difference between the theory and the actual op amp, right? But basically, the quadratic integrating function neuron gives you the most kind of neural modeling capability for the computational cost. Also, it has a analytical solution to it, so it's kind of easy to check it to see whether it's working or not. But basically, you put in a positive voltage and it integrates, and at some point it resets. But it's definitely nonlinear, which is a little more than I want to, you know, we'll get into today. But I guess that's it. I'll just throw it out to questions.
Seems cool that it's, yeah, it seems like a cool application of what we've
Yeah.
learned.
Yeah. And actually, I had a master's student design their own integrated circuit to implement that function. I've had a lot of undergraduate projects where they're building it with op amps, but the latest bunch, yeah. So their final report, like what would, now, yeah, there's things to take this farther. This was their senior project, right? But it gives you an idea. So so one student designed an op amp in 45 nanometers that would be used for quadratic integrate and fire. Then somebody did a small neural network based on the quadratic integrate and fire. That worked pretty well. The chaos circuit, it didn't work. It wasn't the student's fault. It's just there was some weird resetting mechanism that needed to be done, and I couldn't quite figure out how to do it. And then somebody did an analog to digital converter based on that quadratic integrate and fire. And in fact, they showed that even adding noise made it better, which is somewhat where you could say the stochastic resonance is coming from. But you know what? I can. Okay. But anyway, that's really all I have.
Well, thank you.
Yeah, I'll probably
Okay.
take another look at the.
Yeah.
but
I mean,
thank
this
you.
is just a taste, right?
Mhm.
Anyway, I won't be here next week. I'll be on vacation. I'll be in Connecticut. If you guys wanted to meet, I could probably set up an alternative host, and you could, use the same code and all that. Just send me an email. I'll be checking your email periodically, of course. So, all right. But
Okay,
anyway,
yes, sir.
all right. Have a
Hope you
nice
enjoy your
day.
break.
and
Oh, well, have a good vacay.
Okay, I will. I hope you guys all have a good week.
Thank you.
Thank
Bye.
you.
All right. Take care. Bye.